Let's speak a little bit about forecasting and how RTA fits in. So I built a little triangle, which is a real simplified way of looking at life when it comes to looking at doing a production forecast in an EUR in a single well. At the bottom, this is the most popular technique in the world. It's traditional decline curve analysis and also other empirical rate time analysis tools that would address unconventionals. Particularly, I'll mention the An-Duong method, stretched exponential decline, and power law exponential. All these methods that were introduced in the last 6-7 years. These things are terrific because they can be applied to a large well count and they can be done fairly efficiently. Moving up the ladder from that, it doesn't take that much more effort to incorporate the flowing pressure response. With what we could do just using basic wellhead data, or if we had wellbore schematics, we can convert these surface wellhead pressures to a sand face without too much trouble. This would be particularly advantageous for companies that are looking to do just a little bit better than rate decline, especially when you're dealing with highly overpressured, rate-restricted programs where you can't decline a well that's constant rate very easily without applying a rule of thumb. So that pressure information is great. We're seeing more companies do this. Now, going up the ladder from that for an even more accurate answer, RTA, which is very commonly known as being a rate pressure time analysis method, well, it incorporates a little bit more. It incorporates some basic petrophysical considerations and some volumetrics. Volumetrics that can be given to us from our field development strategy, such as well spacing or drainage area. So we believe that this is a very practical approach for getting a really good answer without having to go up to the top of the pyramid, which is going to take us a much longer time to get an EUR or an understanding of reserves across the field, which is what we've generally categorized as reservoir simulation. And by that category, I don't just mean reservoir simulation. I mean bringing it all together. So this would be the product of a fully integrated study that would include things like bringing in the surveillance information like microseismics, fiber optics, tracer data, you name it, frac modeling, the whole bit.